speaking of things that are hardcore to the mega, look at this shit. Woo! God damn. That's real nice looking. Does it I feel like digital image editing in a way has almost ruined the spectacle of deep space photos because, this doesn't look that different from some like photoshopped wallpaper, but like it's actually so insane. It's a real thing, you know? Maybe it would all be better if we had no computers and we had never seen anything like this before, and then NASA was just like, yeah, here you go, and it looks like this. That'd be dope. We can't even have paint, you know? Like we basically we're all just sitting on a farm with like smashing potatoes together to generate heat from friction. Um, so we cook them, and then NASA shows up with these photos, and we're like, oh wow, cool. NASA touches up at space photos? Yeah, of course. So for those of you who don't know, all of these are infrared photos. Infrared isn't just a performance artist on Twitch, or what? No, he got banned on Nick Fuentes' streaming platform. It's also a spectrum of light. Okay, so let me explain, because this is really cool. And just in case anyone doesn't know, because not everyone knows, and there's nothing wrong with that. Basically, all light, visible light, is just a given wavelength range of electromagnetic radiation. Electromagnetic radiation is like basically everything. It's all over the place, okay? And the wavelength determines the properties of the radiation. So you have very, very, very like short wavelengths like this, which is like gamma radiation, and then you get longer and longer and longer and longer, and so on. And then at the longest end, you have like radio waves and stuff. A region of electromagnetic radiation is visible light. It's what we can see. Our eyes have been developed and have evolved to recognize a given range of electromagnetic radiation as visible light. And that recognition, the ability to see the differences in that range of electromagnetic radiation, is what allows us to do stuff on Earth. It's actually really helpful to be able to see in color. However, with red being over here, no, sorry, red's on the longer end. Red is on the longer end of the visible light spectrum. That's why it's at the edge of the rainbow. And if you go further out than the visible light spectrum in the red direction, you get infrared. So infrared light is literally just light that's too spicy for your eyeballs to see. But it's still just like the light that you can see. It's just light that you can't see that's like the light that you can see. It's just a little bit spicier. Or maybe not spicy enough. It's hard to say. Yeah, we're going to watch the Jan 6 hearings. Give me 1 second. Jesus. And on the other end over here, where you have blue and violet as the shorter wavelength, you have ultraviolet, or UV light. No boring Jan 6? Wait, you mean this is boring, Vermin? Or the Jan 6 is boring? Wait, this is good. Wait, hold on. Give me a sec. Come on. Be happy about the universe. Real quick. Okay. Jan 6 is boring. Stay with this. Okay, good. Okay. So basically, okay. You guys know about the Doppler effect? You know how when a car has when it's approaching you, it goes like vroom. You know? The reason for that is because sound is just a compression wave through air. When something's moving and you hear it moving, when it's making noise, that's because it's moving and bouncing against air around it, which is causing shock waves in the air that register to your eardrums, and you can hear it. So if something is moving towards you while producing those shock waves, it compresses the shock waves, which causes them to rise in pitch. And when it's moving away from you, the edge of the shock wave that is traveling towards you is still carrying its momentum from the direction that it was moving in, and therefore it downshifts in pitch. Wait, hold on. Can we just take a second to mock the insufferable bitches in chat? Gilga bro, this is painful when you know basic physics. Well, first of all, I know basic spelling, and you don't, so shut up. And second of all, nothing I've said is wrong. Holy shit. Every time you get specialized knowledge on the stream, people they want to act insufferable. Listen, this is why you can't get laid. It has nothing to do with your looks. This is a personality thing. I have no idea what would compel a person to go, okay, so he's like explaining something, and like he's 99.8% correct, and he's using like language that is entertaining and understandable to a layman, and he's engaged with the issue, but it's like really painful, you know? It's not boring enough for me. It's not, it doesn't even read like a textbook. Shut the fuck up. Jesus Christ. Anyway, so the same way that the Doppler effect can upshift, up-pitch or down-pitch noise depending on whether or not the object is moving towards you or away from you, light can do exactly the same thing. See, everything in the universe is moving away from itself, or away from each other. Everything is moving away from everything. Gravity pulls stuff together on a local level, but the universe itself, the mesh of space-time that everything exists on, expands in all directions at all times. So even if gravity keeps things together locally, the entire mesh grows. And that's not much, you know, that doesn't mean very much to stuff that's like one block down the street, but it does mean that stars that are millions of light years away are moving away from us really goddamn fast. And what that means is that the light that they're emitting, the electromagnetic radiation, is having its wavelength expanded by the movement of the star away from us. Think of it like the coil of a spring. If a spring is being pulled away from you, its coils expand, correct? A little bit like that. If they're moving away from us so quickly that the red light that would normally be emitted from these stars downshifts into infrared, getting long enough that our eyes can no longer see it. That's why space telescopes look at infrared, because infrared is a wide enough electromagnetic range for distant stars to be captured. I return us now to the photo. All this stuff in the night sky. If your eyes could see in infrared the entire spectrum, the entire night sky would be lit up like it's daytime all the time. All of the light that you can't see because your eyes have not evolved to see infrared would shine in the night sky like a dazzling pane of light. It would be impossible to sleep. So thankfully, we can see in infrared. That's probably the reason why living things can't generally see in infrared. It's because it would make it really fucking difficult to sleep. Um, we would have light pollution from space instead of from Earth. I wish my eyes couldn't see infrared, Peepo said. Yeah, look at this. Captured in exquisite detail, the NASA Webb peered through the thick dust of Stephan's Quintet, a galactic cluster showing huge shockwaves and tidal tails. God damn! Look at that! They're making a new galaxy over there. It's 5 galaxies making a new galaxy. You know how much shit's in these spirals? Lots of shit. Hasn't it already happened by the time we see it? Oh yeah. All the light that we're seeing here is giving us an insight into what that looked like as long ago as the distance away it is in light years. If something is like a million light years away, it took a million years for the light to reach us. Meaning that whatever we're looking at is a snapshot of something 1 million years ago. Now, there are stars out there that are way farther away than 1 million light years. So sometimes we go back so far when we look into the depth of space that we're actually looking into the beginning of the universe. See, even beyond all the stars and galaxies in the universe, there's still light. And that light is the the cosmic background radiation from the Big Bang. The Big Bang is still emanating energy from the big explosion some 13 or 14 billion years ago. So farther back, as an outer edge to the universe, like a barrier surrounding all of the universal electromagnetic radiation, there's a haze of Big Bang energy, the cosmic background radiation. And that you can see if you look past all the stars and galaxies. So that's cool. Yeah, the microwave background. Wait, I want to find more cool photos. Woo! Look at that! God, that's pretty. So, when you see photos like this that are put out by NASA, these photos are doctored. They are photoshopped. The reason they're photoshopped is, again, because the James Webb Telescope took these photos in infrared. If they were shown to us authentically, we couldn't see it. It would just be a black square. So, instead, colors are added to approximate the range of infrared light that's seen. So infrared radiation is a pretty wide spectrum of electromagnetic radiation, meaning there are differences within infrared, you know? Like there's lighter infrared and darker infrared, so to speak. Imagine infrared as like a whole other set of colors that you just can't see. And what the scientists do is they just edit the colors in these photos to give it the same color range within the spectrum that we can see. Does that make sense? Why do you know all these things? Because it's interesting. Yeah, shifting into the visible spectrum. Basically, just imagine they're taking the wavelength emanated from all the little bits in the photo, and they're upshifting it into the visible light spectrum while maintaining color differences. So it doesn't literally look like this, but if you could see in infrared, it would look like this, more or less, conceptually. Stupid question, but if I was in there, what would I see? Well, the thing that we're looking at right here is impossibly large. So from inside of this, it probably wouldn't look that different from being on Earth looking out into the stars today. Well, wait, hold on. NASA Webb shows a dying star cloaked by dust and layers of light. Never mind, this is not a galaxy, this is a dying star. You would die. My bad. I thought this was a galactic cluster or a, like stardust. No, you'd be dead. Sorry. It would be very bright for a second, and then you would be gone. If you look far enough into deep space, you get to see the really cool stuff because, again, you're looking into the past when you look deep into space. And if you look far enough into the past, you begin to see the photos of the universe back when the universe was spicier. Back when all the big galactic clusters were still like smashing together, you know, back when the universe was more violent and aggressive and angry. You can see that if you peer far enough into the past, if you peer far enough into the distance. See some of the earliest galaxies. There we go. This is the big photo. Look at all that crap. Whew! A lot of stuff out there. So you're saying we can see the Big Bang itself? Well, half and half. We can see the remaining energy from the Big Bang represented in the cosmic background radiation. We can see evidence of it, kind of like the glow after effect. The problem with going back far enough to see the Big Bang itself is that the Big Bang doesn't just represent like a big explosion in space. It represents the beginning of space-time as we understand it. It's like, I'm trying to think of it. Like, from from a space-time perspective, looking back into the Big Bang would be kind of like trying to peer inside of your own eyeball, unassisted from the perspective of your own eyeball. There's not really a physical way to identify a spatial region that would have been the Big Bang because space-time was the Big Bang when the Big Bang happened, you know? It's everything. So we are looking at the Big Bang kind of all the time. There's not really an origin point though, you know? Um I'm trying to think of an example. I guess imagine okay, I think I have it. Imagine an empty balloon, like a party balloon that then gets filled up with air. Trying to find the Big Bang would be like looking into the empty balloon and trying to find the portion of the space within that balloon that represents the air that was there before it got filled up. It's not even like a mathematically identifiable there's not really a way to to contextualize its position relative to the way I could do that easy. Yeah, maybe it's kind of difficult to find analogies here because we're kind of talking about like space time. But yeah, yeah, it's difficult, you know. Um, you're giving me an existential crisis. Nah, dude, this shit's cool. It's the wavelength of infrared for 4'7". True. This shit's super cool. Have you please talk about the Hunter Biden iCloud? I don't care about Hunter Biden. Conservatives will never psyop me into caring about Hunter Biden. I don't care. Every once in a while, people remind me that he fucks hot chicks and smokes crack, and I don't know what I'm supposed to do with that information. Like, cons run up to me with a bunch of photos, and they're like, look, look, Hunter Biden has a fat cock, and he's fucking supermodels, and he does lots of drugs. And I'm like, okay, thank you. Are you okay? I don't know what I'm supposed to do with this information. Yeah. Yeah, I don't know. Anyway, yeah, these photos are really beautiful. If we have 3 points to record the infrared light, would we be able to see how the galaxy was formed? No, because the thing about the Big Bang, it's not like you had space, and the Big Bang was the cluster of all the mass and energy in one place, and then the Big Bang happened, and it exploded into space. Space was the Big Bang. Space-time didn't really exist back then. It was like a crumpled ball of paper, you know? Oh, that might be a good example, right? It's like, okay, yeah. It's like you have a really big sheet of paper that you crumple up into a little ball, and that's meant to represent the Big Bang, and then you unfurl it back into a big sheet of paper, and then you point to the paper and go, okay, now can you identify where on this sheet of paper the crumple was? Like, where was it crumpled? And it's like, the crumple was the paper. Crumpled. The paper compressed into one space was where it was. There's no space on the paper that was the crumpled paper. The paper was the crumpled paper. That makes no sense? No, you know what, okay, okay, imagine, okay, okay, you have a crumpled ball of paper. It's a really big sheet of paper, and you've crumpled it into a ball, okay? And it's the Big Bang. And it expands out into a regular sheet of paper, albeit crumpled. And you're an ant. You walk atop the sheet of paper, atop a two-dimensional plane as an ant. And you're a scientist ant. And somebody asks you, where on this paper was the crumpled paper? It's not possible to answer, because the crumpled paper represents all of that paper compressed into a single space. There's no place on the paper where the crumple happened. The paper is the crumple. That's just in 2 dimensions. The Big Bang is like that, but in 3. You see? Imagine a 3-dimensional sheet of paper expanding infinitely in all directions, and its origin point was an initial crumpling that it has since emanated from. There's no point on that 3-dimensional paper that the Big Bang happened. It was the Big Bang. Okay, does that make sense? That's the best I can do, I think. That's the best I can do on the fly. There are probably better, like, explanatory YouTube videos. That's the best that I can do, just, like, off the cuff. Time is a dimension? Yes, time is the 4th temporal dimension. Yeah. Where does Marx fit into all this? Yeah. Vosh not knowing how to say relativity. I don't need to explain relativity to talk about, like, the idea of space-time only beginning to exist with the Big Bang. You can give a layman's explanation. I'm not a scientist. Gravitational lensing? Oh, God. Okay, so, as I understand... Okay, so, remember how we... remember how we talked about the crumpled paper? So, the paper is analogous to space-time. Space-time is 4th dimensional, 3 spatial dimensions, and 1 temporal one. And the paper is going to be 3-dimensional, that is to say, 2 spatial ones and 1 temporal one. So we're lowering 1 dimension by pretending that paper is a truly flat plane, okay? That's what we're trying to do here, okay? And general relativity is like the idea that gravity and other things are warped spatially alongside the dimensions. It, I don't care anymore. It's fine. You are wrong. Thanks, guys. Listen, all I know is this, okay? When they program the clocks on satellites, they have to program them to run, what is it, a little bit faster? Yeah, a little bit faster. Relativity has already been proven mathematically. We have to. If satellites and clocks on Earth are both programmed to run at the exact same time, the satellite's clock will eventually run slow. Ain't that weird? Or is infomaterialism and all this? Yeah. How do you do the math on that? I don't know. That's from Solar Wind, dumbass. No, it's not. Shut up. You're just trying to confuse me. That's your video game idea, Finhills? Yeah, yeah. Where'd you hear that time is fourth dimensional? Never heard that said except by middle schoolers. No, it is. Those are the dimensions that we can perceive. The four of them. You have three spatial dimensions that you all know, and the fourth dimension is it moving through. It's like the box that everyone draws. It's like this, right? So you can have a one-dimensional point. Whoa, that was, oh my dude! I just free-handed that shit. Oh my god. What? Wait, what? I didn't hold shift or anything. That was with the fucking mouse. Are you kidding me? Oh my god. Holy fuck. Channeling the divine energy for a second. Okay. That's what I talk about space for a minute, and the fucking secrets of the cosmos are being unlocked. That's a perfect 90-degree angle. Okay. Alright, well, clip that. Alright, well, getting back to my regular shitty... Yeah, that's what it looks like normally. Okay. Boy, that was weird. Anyway, you have a two-dimensional plane, okay? And then you have, the three-dimensional box, which looks like shit, right? Okay? But then you can have... How do you draw it again? It's like, It's like... The goddamn... I already fucked this up. It's like it's like that, right? The hypercube shit or whatever, and the fourth dimension represents time, and shit moves through. Is that what a tesseract is called? No, not a tesseract. It is? Those are the same thing? Oh, well, whatever. A tesseract is a four-dimensional cube? Oh, okay. Alright, well. Yeah, cool, whatever. Wait, as much as struggling to see you draw a tesseract is funny, tesseracts are based on a fourth spatial dimension, not a temporal dimension? No! You guys lied to me! Wait, where's that 4D video game? That would be a good way of showing. Wait, hold on. 1 sec, then we'll do Gen 6. 4D video game. Wasn't there like a trailer for that? Yeah! This shit came out ages ago. I wonder if this game ever came out. Hold on.
There's a fourth dimension of space. So I thought I would show you what it would actually look like if you could walk through walls using the fourth dimension. And in the process, explain what the fourth dimension is. So say you need to get and you can't walk around it. But what if there was more to this world? What if you could just walk around the wall in the fourth dimension? So you turn to face along the fourth dimension, walk along the fourth dimension, and turn back. You discover that the wall has disappeared, and it's been replaced by a pile of rubble in the middle of a desert. Okay, before I continue, let me explain something first.
Wait, I think this is 4 spatial dimensions and not a fourth temporal dimension.
What does he see when he turns sideways? He might think the world is deforming, but it's just what it would look like if you took 2D slices of a 3D object, like images produced by an MRI machine, for example.
See? Okay, yeah, no, this is what I mean. This is like a 2D to 3D variant.
2D, so unlike
Look,
us, he can't see the third dimension. So what does he see when he turns sideways? He might think the world is deforming, but it's just what it would look like if you took 2D slices of a 3D object, like images produced by an MRI machine, for example.
Literally any video of 3D space would be a fourth temporal dimension? Yeah, well, depending on how it's represented. Like, we're talking about artistic representation here. Obviously, for us humans who have, like, a finite temporal perception, any fourth dimensional shenaniganry is going to have to be represented as a fourth spatial dimension in media, because we're not capable of altering our time perception on the fly for, like, media consumption. The fourth dimension is the passage time. Okay, yeah, I know that, but, like, explain that to someone else. Dude, would you like to try one of our 4D, milkshakes, sir? 4D milkshakes? Yeah, sure, here, $13. This better be worth it. What's special about it? Oh, well, it exists in 3 dimensions, and there's a fourth temporal dimension as represented by the fact that it's now in your stomach. Thank you for the money. Woo! Like, yeah, we know that, like, the fourth temporal dimension is omnipresent because we perceive the passage of time, but when we talk about 4D shit, we're talking usually about representing that temporal dimension spatially, because we can't literally alter our, okay, like Prince of Persia would be a 4D game if you literally interpreted the time rewind mechanic as like a manipulation of temporal fourth dimensional mechanics, which again it is, but so is everything. If moving back in time is a 4D game, then so is moving forward in time. But you can't call every video game a 4D video game, or call fucking Super Mario World a 3D video game, because you have 2 spatial dimensions and a third temporal dimension, because when you jump, time passes and then you fall. All right, okay, stop. No, stop. We're doing Gen 6. All right, everyone, back it up, back it up, back it up. Back it up. I'm a linguistic prescriptivist now, okay? Dude, check out this new 4D game, Assassin's Creed Origins. Notice how things happen in one direction when you hit buttons? Alright. What if we had 2 temporal dimensions? I mean, it's theoretically possible, right? I just can't conceive it. I've heard someone say it's theoretically possible, but... Alright. Do string theory? Nah, fuck. Dude, every time I hear people describe string theory, it sounds like some dipshits got really high and wanted, like, some awards. So they were like, okay, dude, I know this doesn't sound like it makes any sense, but just let me establish, like, 87 givens, and once we set all those in motion, this will all make sense. You know? Definitely a little bit more contrived of the... Please do not explain string theory. I couldn't if I wanted to. What about dark matter? What is dark matter? Puh, he doesn't even know dark matter is. Isn't dark matter just supposed to be matter that doesn't interact with light, but it still interacts with gravity or something? Isn't it just supposed to be something that explains, like, gravitational anomalies, but it doesn't affect, like, the passage of light? Physics is so easy. Dude, I fucking wish sociology was like physics, you know? Physics people, they can be like, yeah, our model doesn't work, so there's invisible magic. and if you're willing to account for the invisible magic in the universe, then our models continue to work. Dude, I'm not shitting on them. I respect the fuck out of that. That's based as hell. All right, we're moving on. We're moving on.